Hello everyone and welcome to my presentation. I hope you're doing very well. My name is Alex Ruley and I'm a second-year geology master's student in the Department of Geology and Environmental Earth Science under the advisement of Drs. Mark Krekeler and Claire McLeod. And today I'll be talking with you about pyrite chemistry as it relates to one of the leading gold mines in the US. So here's my research site. It's named Round Mountain Gold Mine and it's located in central Nevada, as we can see here with a right-hand map. In this red circle here is the exact location of the mine, symbolized by these crossed pickaxes. And we can see here it's right up against the Toquima mountain range in central Nevada for the geographic perspective. And right now it is owned by Kinross Gold. They're a large multinational gold mining corporation with operations throughout the Americas and beyond. And right now at this mine in particular, they are using the open pit style for mining. So here's a picture of the open pit. And essentially what they do here is they dig down and make these angled bench terraces, which essentially act to prevent any collapses in the mine. So there's quite a bit of engineering involved as well as geology. And just to give you a sense of the scale here, the hole or the pit at this state was about 2,000 feet deep and about a mile across. So the scale is quite large here. And they continuously dig deeper to this day. So right now, or in the recent past, this mine has been one of the top producing gold mines in the U.S. And just last year, they produced 11 tons of gold. So quite an appreciable amount of gold. And where that gold comes from specifically might surprise you. So enter pyrite. So let's talk about pyrite chemistry. So pyrite is a sulfide mineral with the formula iron disulfide, and it can have various mineral inclusions in it. And that just means that it can have different minerals embedded within it. So it can have things like galena, which is a lead mineral, and sphalerite, which is a zinc mineral. And it can also have various elements that substitute in for the elements in pyrite. So some of those are toxic, such as arsenic, cobalt, mercury, and lead, and then some of those can be valuable, like gold, silver, zinc, and platinum. And gold is really the only profitable one on that list. Pyrite is associated very commonly with gold in certain gold deposits, such as Round Mountain. So off to the right here, we can see some gold crystals that are very well formed, and they are cubic, which is a result of their crystal structure. And then on the bottom here, this is a chart showing the relative proportions of different elements in a pyrite crystal from Round Mountain. So we have the usual suspects, iron and sulfur, as well as a host of other elements at much smaller concentrations, and we would call those trace elements. So those include aluminum, arsenic, silicon, and even vanadium here we can see over here is just a little blip on the chart. But vanadium is not a very common substituent element in pyrite, so I'll be taking a closer look at that in my research. So again, gold and pyrite, what the heck? This is not, a common thing that people come across. Usually when you think of gold, you think of big gold nuggets like this picture on the left here. But actually, the majority of the gold mined in the world comes from pyrite, surprising as it may sound. And so actually what we're more concerned about is this kind of pyrite-rich ore that we see on the right-hand side, which is a piece of ore from Round Mountain. But again, this is invisible gold. The pyrites in this are incredibly small. They're on the micron scale, which is very, very small. So we need specialized techniques to look at these pyrites. So this is an example of a suite of research techniques that one might use to study such pyrites and the gold within those pyrites. And this is the suite of techniques that I'm using in my research. So first we start with light microscopy in order to characterize the texture and the shape of the pyrite crystals as they occur in the host rock. And then we move on to more higher level techniques, such as electron microscopy, where electrons are used to study the surface of the material. And that produces images like the one directly below this picture right here, where we have a pyrite crystal embedded in some of the host rock. I believe this is feldspar surrounding the pyrite, and excuse me. The scale here is 100 micrometers for this scale bar. So we're talking about the width of a human hair. So this pyrite is smaller than the width of a human hair. So very, very small pyrites, but you get enough of them with enough gold in them, and you can have a profitable mine. And in order to get at that gold concentration, the gold concentration is actually so low that we need a very specialized form of mass spectrometry called laser ablation inductively coupled plasma mass spectrometry. And that is shown in the image here on the right, and it produces data such as this chart on the bottom right. And this is showing gold concentration in a pyrite grain, where warm colors are high concentration and cold colors are low concentration. So here we see there's an association with between the rim and high gold concentration. So that's something to look at as well. All right, and the main thing with Round Mountain Mine is there's a very diverse range of ore types. So the key is to study the pyrite and its different trace elements and gold concentration specifically, and any associations that gold concentration might have with other trace elements in order to better understand the history of the ore deposit, essentially, and specifically pyrite mineralization because of its importance as a gold hosting mineral. And what's also important is studying various trace elements that we might not often see in pyrite, and studying and theorizing why exactly those might be there in order to unlock the secrets of this gold deposit and apply those to other gold deposits. So that brings us to the end. Thank you very much for listening, and please, if you have questions, take them down and I will be more than happy to address them in the Q&A session. Take care.